Find the linear inequations corresponding to the shaded region. Okay, let us begin. So here we have three equations. Let's start with the equation x minus y equals to 1. Now we have to convert it into an inequation. So there are two possibilities. Either it could be x minus y greater than or equals to 1, or it could be x minus y less than or equals to 1. Now clearly we have to consider a solution which lies above the line. That means that's because our shaded region lies above the line x minus y equals to 1. Now if it is lying above the line, that means it is also going to include the point 0, 0, or in other words we can say 0, 0 must satisfy one of the inequality. So let's choose the point 0, 0. So if we choose the first inequality, we have 0 greater than or equals to 1. And if we choose the second inequality, we have 0 minus 0, that's simply 0 less than or equals to 1. We know the first inequality is going to be untrue because 0 cannot be greater than 1, which leaves us with the possibility that x minus y has to be less than or equals to 1. So this gives us the first inequality. Okay, let's go to the next equation. So we'll consider 2x plus y equals to 2. We have 2x plus y equals to 2. So we'll consider two cases. So we have 2x plus y greater than or equals to 2, or we're going to consider the case that 2x plus y is less than or equals to 2. Now according to this figure, our solution must lie above the line 2x plus y equals to 2 because the shaded region lies above this line. That means it has to exclude the point 0, 0. In other words, we can say if we substitute 0, 0 into one of the inequality, it should not satisfy the inequality. So at 0, 0, the first inequality gives us 2 times 0 plus 0, that's simply 0. 0 is greater than 2. Or we have 2 times 0 plus 0, that's 0 less than or equals to 2. So here we're getting the case where 0 does not equals to 2. This simply tells us that the point 0, 0 is not a solution of 2x plus y greater than or equals to 2. And this is the only possibility because our solution, our inequality should not include 0, 0. It's lying below the line 2x plus y equals to 2. Fine. Let's go to the third equation. We have x plus 2y equals to 8. We have x plus 2y equals to 8. So that also gives us two possibilities. We have x plus 2y greater than or equals to 8, and the second possibility could be x plus 2y less than or equals to 8. Now for this line, we need a solution to lie below the line because the shaded region lies below the line x plus 2y equals to 8. Now if it is lying below the line, that means the point 0, 0 must satisfy the inequality. So let's check. So if we put 0 in place of x and 0 in place of y, we have 0 greater than or equals to 8. So this is untrue. Whereas the other case, we have 0 less than or equals to 8. This is a true case. So that means the first one is not going to be the possibility. We can only have x plus 2y less than or equals to 8. So here we have successfully obtained all the inequalities. Now let's label them up. So we have x minus y. This is going to be less than or equals to 1. We will not be considering this case. For the second inequality, we obtained that 2x plus y must be greater than or equals to 2. The third possibility gives us x plus 2y less than or equals to 8. And since we have in the first quadrant, so we'll have to consider x to be greater than equals to 0 and y to be greater than equals to 0. So this is going to be the set of linear inequation which satisfies the shaded region.